If you took the train from London to Edinburgh at any point between 1961 and 1981, a Napier engine was almost certainly pulling you, two of them screaming at a pitch that drowned out every platform announcement at King's Cross. At its peak, D. Napier and Son employed 10,000 workers across factories in Acton and Liverpool, building engines for the Royal Navy, the Royal Air Force, and British Rail. They survived 2 world wars, survived the shift from motor cars to aero engines to diesel power, survived a government-directed takeover, and came back with the most extraordinary locomotive engine Britain had ever produced. And then, after 166 years of making, the name was simply erased. How does a company whose engines won a war and transformed a railway just disappear? What really happened? Chapter 1. The Blacksmith's Grandson. The story begins, as so many British engineering stories do, with a man who came south. David Napier was born in 1785 in Dumbarton, Scotland, the second son of the blacksmith to the Duke of Argyll. His cousins Robert and David stayed on the Clyde and built ships that would make the Napier name famous in maritime circles from Glasgow to Constantinople. David chose London instead. In 1808, aged 23, he walked into Henry Maudslay's workshop, the most advanced precision engineering operation in Britain, and began learning the trade that would carry his family's name for 166 years. He was good. By 1815, he was works foreman, running Maudslay's men near Fleet Street. 3 years later, he went into partnership with a stationer named Francis Basler at Lloyd's Court, St. Giles, and began building what he knew best, machines that made things. The first Napier products were steam printing presses, the kind of precision equipment that Hansard and the major London newspapers needed to keep their pages running. Basler left the partnership in 1822, but the work kept coming. In 1830, the firm moved south of the river to Lambeth, and by 1836 it occupied larger premises on York Road, specialising in printing machinery, but branching out wherever David's restless engineering mind took him. And it took him everywhere. A bullet stamping machine, patented in 1840, sold to Woolwich Arsenal. Coin-weighing machines for the Bank of England in 1842, then the Royal Mint. Double-sided printing presses. Centrifuges for the sugar refining trade. Lathes, drills, and railway cranes. Between 1840 and 1860, the York Road Works employed 200 to 300 men, and an award at the 1851 Great Exhibition, Prince Albert's vast celebration of British manufacturing supremacy, marked the high point of David Napier's career. He'd come south with nothing, built a respected engineering firm from scratch, and earned recognition from the nation's grandest industrial showcase. His younger son, James Murdoch Napier, had joined the business in 1837 at the age of 14 and became a full partner in 1847, the year the firm officially became D. Napier and Son. James took over entirely when David retired in 1867, and for the next 3 decades, he ran the business with the exacting standards of a clockmaker. His speciality was machines for making coins, stamps, and banknotes, equipment so precise that Thomas Curson Hansard praised it as machines as delicate as any clock could be. But James Murdoch Napier was, in the words of the company's official historians, Wilson and Reeder, an excellent engineer, but a poor businessman, considering salesmanship undignified. He built beautiful machines. He refused to sell them with enthusiasm, and by the time of his death in 1895, D. Napier and Son had shrunk to 7 men working in a near-silent workshop. 7. A firm that had once supplied the Arsenal, the Mint, and the Empire's newspapers was now barely distinguishable from a backstreet jobbing shop. This is where the story might have ended. A footnote in Victorian engineering history, a name on a Lambeth lease, forgotten, except that James Murdoch Napier had a son, and his son was nothing like him. Montague Stanley Napier was born in 1870 at 68 York Road, Lambeth, grew up surrounded by his father's precision machinery, and developed, unusually for the son of a man who considered salesmanship beneath him, a fierce competitive streak. He was a keen racing cyclist with the North Road Cycling Club, the kind of young man who understood speed and wanted more of it. When his father died in 1895, Montague bought the dying business from the executors and immediately pivoted to the one trade where his passion for velocity and his inheritance of precision engineering intersected: machine tools for the booming bicycle industry. It was a smart move, but it wasn't the move that changed everything. In 1899, Montague Napier met a man named Selwyn Francis Edge. Edge was Australian-born, 31 years old, the sales manager for Dunlop, and one of the most naturally persuasive individuals in the British motor trade. He'd bought a French Panhard Levasseur car and was unhappy with its temperamental hot-tube ignition system. He asked Montague to fix it. Montague looked at the Panhard, decided he could do better than fix it, and designed his own engine from scratch, an 8-horsepower vertical twin with electric ignition that was, by every measure, a superior piece of engineering. The first Napier car appeared in April 1900, 5 days before the Automobile Club's 1,000-mile trial. Edge drove it. He won a silver medal. And from that moment, the two men, the obsessive engineer and the born salesman, formed a partnership that would transform D. Napier and Son from a 7-man workshop into the most admired car manufacturer in Edwardian Britain. Edge persuaded Harvey de Cross, the founder of Dunlop, to form the Motor Power Company to buy Napier's entire output at £400 per car and sell them on at £500. Montague, freed from the indignity of selling, threw himself into design. In 1900, he built the first ever production 6-cylinder car. In 1902, Edge drove a Napier to victory in the Gordon Bennett Cup, the first time a British car had won an international motor race. By 1903, production had reached 250 cars a year, and the York Road premises in Lambeth were hopelessly inadequate. Montague needed a factory. He found his ground in Acton. Chapter 2. Motortown. 3 3/4 acres on the south side of Uxbridge Road in Acton Vale, just outside the London County Council's building restrictions. That was where Montague Napier planted his flag in 1903. He commissioned a stone-faced brick factory from the architect Robert Thompson, complete with a grand entrance foyer so impressive that the workers nicknamed it Piccadilly Circus. Visiting customers would be ushered through that foyer, past gleaming motor cars, and for a few years at the turn of the century, a Napier showroom was among the most prestigious addresses in British manufacturing. Acton Vale was on the cusp of becoming Motortown. Within a year of Napier's arrival, 500 workers filled the new works. By 1906, 1,000. By 1907, 1,200 men producing 200 cars a year, alongside a growing range of marine engines. In 1905, Napier 2 set a world water speed record at almost 30 knots. The name was becoming synonymous not just with quality motor cars, but with speed itself. The idea that British precision engineering could outrun anything the French or Germans or Americans could build. The partnership with Edge brought fame, but also friction. In 1912, following a bitter dispute, Montague bought out Edge's distribution company. Production that year peaked at 700 cars, many of them supplied to the London taxi trade, a more prosaic market than the Gordon Bennett Cup, but a profitable one. The same year, Montague's health began to fail. What was almost certainly cancer forced him, by 1915, to move permanently to the Villa des Sisters in Cannes. He would never return to Acton, but he continued to direct engineering policy by post, long, detailed letters to his managers, insisting that the firm would remain relatively small and very highly specialized rather than becoming a giant of mass production. It was a philosophy that would define Napier for the next 3 decades and ultimately limit its chances of survival. Day-to-day management fell to Harry Tempest Vane, who'd been managing director since 1912. Design was led by Arthur John Rowledge, a bricklayer's son who'd been hired as chief draftsman in 1903, risen to chief designer by 1913, and possessed the kind of quiet engineering brilliance that Montague recognized as equal to his own. When war came in 1914, the Air Ministry contracted Napier to build other firms' aero engines, the V-12 RAF-3 and the Sunbeam Arab. Both were unreliable. Both embarrassed the Acton works. In 1916, Montague, writing from Cannes with the authority of a man who owned the firm outright, offered to design a Napier engine entirely at the company's own expense. The Air Ministry accepted. What followed, completed under Rowledge's direction in late 1917, was the machine that made D. Napier and Son a name that mattered beyond motor cars. The Napier Lion was a 24-litre, 12-cylinder, broad aero W12. 3 banks of 4 cylinders sharing a common crankcase, aluminium construction throughout, 4 valves per cylinder with twin overhead camshafts on each bank. For 1917, this was extraordinarily advanced. The first hand-built prototypes ran in late that year, and the production Lion Y delivered 450 horsepower from June 1918, immediately overtaking the American Liberty L12 as the most powerful Allied aero engine. Meanwhile, the Acton works had expanded to 8.5 acres, employed around 1,700 people, and was assembling complete aircraft alongside its engine work. 50 RAF RE-7 reconnaissance planes, 400 RE-8s, 150 Sopwith snipes, plus 2,000 trucks and ambulances for the War Office. But it was the Lion that carried Napier into the 20s. By 1924, about half of all British military aircraft were powered by the Lion W-12, and over 3,000 units were built before production finally ended in 1932, serving in more than 130 aircraft types across the British Empire. A marine derivative, the Sea Lion, powered RAF rescue launches. The Finnish Air Force fitted Lions to aero sledges, and when the engine was tuned for racing, it became something almost otherworldly, reaching 1,300 horsepower in sprint configurations that would have astonished the men who'd built the first 450 horsepower version. The records fell like dominoes. Lion-powered supermarines won the Schneider Trophy in 1922 and 1927. Malcolm Campbell's Bluebird took the world land speed record in 1927. Henry Seagrave's Golden Arrow, a lion under that streamlined skin, raised it again in 1929 at 231 miles per hour. And then John Cobb's Railton Mobile Special, carrying 2 highly tuned Lions, set a record at Bonneville of 394 for 196 miles per hour in 1947 that would stand until 1963, when Craig Breedlove finally beat it. An engine designed in 1916 held the world's fastest on-land title for 16 years after the Second World War. Britain held the land speed record continuously for 32 years, and the Napier Lion was the reason. Montague, directing affairs from the Riviera, might have felt satisfied. Rowledge had gone to Rolls-Royce in 1921, lured away to work on what would become the Merlin. That departure was an omen, though nobody read it that way at the time. Car production wound down and ended in 1924, 4,258 cars in total. An attempt to buy the bankrupt Bentley in 1931 was outbid at the last moment by Rolls-Royce. When Montague died on 22 January 1931, the company he'd rescued from 7 men had peaked as a world-class aero engine manufacturer and was now drifting without a clear successor product. Major Frank Bernard Halford, already famous as the designer of the de Havilland Gypsy, was contracted from 1928 and became Napier's technical director in 1935. His air-cooled H-block designs, the 16-cylinder Rapier and the 24-cylinder Dagger, were technically inventive but commercially modest. The 1,000-horsepower Cub was rejected by the Air Ministry. A licensed Junkers Jumo 204 diesel, the Culverin, and its variant, the Cutlass, were both abandoned when war broke out. By the late 1930s, Rolls-Royce had the Merlin and Bristol had the Hercules. Napier, the firm that had dominated British aero engines for a decade, was falling behind. Halford's response was a single, all-or-nothing bet: the sleeve valve H-24 Saber. Chapter 3. The engine that nearly broke them. The Saber was the most ambitious piston aero engine ever attempted in Britain. Designed under Halford from 1935, it was a liquid-cooled, horizontally opposed H-24 with 2 crankshafts geared to a common drive shaft, sleeve valves developed alongside Sir Harry Ricardo's research, and a displacement of 36.7 litres. The first prototype ran at Acton on 17 January 1938, producing a limited 1,350 horsepower. By March, it was passing tests at 2,050. By June 1940, the Saberwaffen cleared the Air Ministry's 100-hour type test at 2,200 horsepower, the first hyper-engine to actually work. Later marks would push to 2,400, then 2,615, and ultimately, with the Saber 7 and water methanol injection, an astonishing 3,500 horsepower, the most powerful piston aero engine in the world. The aircraft that carried it would become legendary: the Hawker Typhoon, the Hawker Tempest, the Napier Heston Racer. On 12th September 1942, a Martin Baker MB-3 prototype suffered a Saber seizure in flight that killed company co-founder Captain Valentine Baker, a reminder that this engine, for all its power, was not yet tamed, and taming it nearly destroyed Napier. The Saber's sleeve valves were manufactured from chrome molybdenum steel and suffered catastrophic out-of-roundness. Engines failed after 25 hours. Saberless Typhoon airframes accumulated at Hawker's factory. When a good engine became available, it would be installed. The aircraft flown to a dispersal airfield, the engine removed, and shipped back to be fitted to the next airframe in the queue. It was an absurd, desperate improvisation, driven by an engine that couldn't be made reliably in quantity. In October 1941, Rod Banks replaced George Purvis Bullman as the Ministry of Aircraft Production's Director of Engine Production. Banks understood the problem. Napier's Acton Works was a craftsman's shop, not a mass production facility. Under intense Air Ministry pressure, Bristol, which had solved similar sleeve valve problems on its own Hercules engine, was forced to share its patented nitrided austenitic steel sleeve technology with Napier in 1942. Bristol's well-machined sleeves resolved the worst failures, but the damage to confidence was done. The rescue came in December 1942, and it came wearing a suit. Sir George Horatio Nelson, chairman of the English Electric Company since 1933, bought the ordinary shares of D. Napier and Son, Limited. The transaction was concluded at the direction of the Ministry of Aircraft Production. Sir Stafford Cripps, who'd taken over as minister in November 1942, had the authority and the will to force it through. The existing Napier board had effectively failed to industrialise the Saber. English Electric's mass production capabilities were the cure. The price paid for those ordinary shares has never surfaced in any publicly available source. It likely sits in Wilson & Reeder's company history or the Institution of Mechanical Engineers archives, waiting for a researcher to find it. Nelson installed himself as Napier's chairman and sent his son, Henry George Half Nelson, 25 years old, already superintendent of English Electric's Preston Works, to run Napier as managing director. Harry Tempest Vane, the man who'd managed the firm since 1912, was effectively displaced. He died the following year, in 1943. Frank Halford, the designer whose genius had created the Saber, but whose temperament couldn't survive a corporate takeover, resigned as technical director. De Havilland bought out his consultancy in 1944, and Halford went on to design the Goblin and Ghost jet engines for the Vampire and the Comet. Engines that would define Britain's jet age, while Napier remained tethered to pistons. The man who stayed was Ernest Edward Chatterton, chief engineer of the piston engine division. Chatterton took over Saber development from Halford and, under English Electric's new regime, Sundstrand centerless grinders, rigorous quality control, mass production discipline imposed on what had been a handcraftsman's operation, turned the Saber into a reliable war-winning engine. By 1944, Saber Vesses at 2,400 horsepower were rolling off the lines at both Acton and the vast Liverpool shadow factory. That Liverpool plant deserves its own moment. Deemed too vulnerable to bombing, the Acton works alone couldn't carry wartime production. In October 1939, the decision was taken to build a shadow factory on the East Lancashire Road in Liverpool. Construction began in 1940 with essential Acton staff supervising. The finished facility covered more than 1 million square feet of factory floor, a vast, purpose-built engine works that dwarfed the original Acton site. The first fully tested Liverpool-built Saber II was delivered in February 1942, just 13 months after Acton's first production engine. By war's end, approximately 5,000 Sabers had been built in total, roughly 3,500 from Liverpool, 1,500 from Acton. The total D. Napier and Son workforce exceeded 10,000. Every Hawker Typhoon that roared across the Channel in 1944, on its way to destroy a German tank column in the bocage around Falaise, carried a Napier Saber under its cowling. Every Tempest that intercepted a V-1 flying bomb over Kent ran on Napier power. The Saber had nearly broken the company. It had been rescued by government intervention and a corporate takeover that cost Napier its independence forever, and it had helped win the war. But the takeover of December 1942 was both a rescue and an annexation. From that month onwards, D. Napier and Son was no longer an independent voice in British engine policy. It belonged to English Electric, and English Electric had plans of its own. Chapter 4. 3 crankshafts in a triangle. In 1943, while the Saber was still being wrestled into reliability, the Admiralty established a committee with a specific problem. Britain's motor torpedo boats ran on petrol engines, and petrol-engined MTBs had a fatal tendency to catch fire when hit. The Royal Navy needed a lightweight, high-powered diesel for its fast patrol craft. Sir Roy Fedden, formerly of Bristol, proposed a sleeve-valve H-block diesel. English Electric proposed something far stranger, that Napier, drawing on its experience with the Junkers Jumo 204 opposed piston diesel it had built under license as the Culverin, and its hard-won expertise with the Saber's H-block configuration, should develop an entirely new kind of engine. They called it Deltic, after the Greek capital letter delta, D, the triangle. The engineering was, even by the standards of an industry that had just produced 3,500 horsepower piston engines, borderline insane. Take 3 banks of 6 cylinders. Arrange them in an inverted triangle. Place a crankshaft at each apex. In each cylinder, put 2 pistons facing each other. No cylinder head, no poppet valves, just ported intake and exhaust, with the pistons moving towards a common combustion space in the middle. Link each crankshaft to 2 adjacent pistons in different cylinders using fork and blade, connecting rods. Make each cylinder's exhaust piston lead its inlet piston by 20 degrees of crankshaft rotation, producing 40-degree firing intervals in each bank and a charge ignition every 20 degrees of crankshaft revolution overall. The result was an 18-cylinder, 88.3-litre, opposed piston 2-stroke diesel that produced 2,500 brake horsepower at 2,000 revolutions per minute, weighed roughly half as much as a conventional diesel of equivalent power, and occupied about a fifth of the space. The design work began under Ernest Chatterton, with Ben Barlow and George Murray doing the principal engineering alongside him. Herbert Sammons took over project management in 1949. The crucial geometric breakthrough, the realization that one of the 3 crankshafts had to rotate anti-clockwise relative to the other 2 to achieve correct piston phasing, was suggested by Herbert Penwoodden, a senior draftsman at the Admiralty Engineering Laboratory. Without that insight, the triangle wouldn't have worked. With it, the engine became mechanically possible, if brutally complex. The first 18-cylinder Deltic D18 ran on the testbed in April 1950. To prove the concept, the engineers did something characteristically audacious. They installed 2 Deltics in a captured German E-boat, replacing 2 of its original Mercedes-Benz diesels. The Deltic delivered the same power in half the size and 1/5 the weight. For the Royal Navy, this was a revelation. Dark-class fast patrol boats, Ton-class minesweepers, Hunt-class mine countermeasures vessels, the Deltic became the standard British naval diesel of the post-war era. Norwegian Navy Nasty-class MTBs used turbocharged variants, which led to United States Navy orders for the same patrol boat hulls during the Vietnam era. By the end of 1966, Napier's Liverpool works had manufactured its 500th Deltic engine, but the truly extraordinary chapter was about to be written on land. In 1953, a short article in Model Engineer magazine suggested that the Deltic's extraordinary power-to-weight ratio might suit railway traction. Sir George Nelson and his son, Half Nelson, seized on the idea, against opposition from English Electric's own traction division at Preston, who were busy selling their Type 4 diesel, a perfectly competent but profoundly uninspiring locomotive that weighed 133 tons and produced only 2,000 horsepower. The prototype Deltic locomotive, internal project title Enterprise, officially designated DP1, was begun at the Dick Kerr Works in Preston in 1954, completed in autumn 1955 in English Electric's blue and cream house livery, moved by road to the works at Netherton in Liverpool for static tests, and entered revenue service from Edge Hill Depot on 13th of December 1955. DP1 ran London, Euston, Liverpool fast freights, then graduated to passenger services, the Shamrock and the Merseyside Express on the London Midland region. The LMR's chief mechanical and electrical engineer, J.F. Harrison, was unimpressed. He doubted a 1,500 RPM engine could be reliable in railway service. The prototype was politely returned, but the East Coast Main Line needed a saviour. The English Electric Type 4, for all its dependability, was no faster than a Gresley A4 Pacific, a steam locomotive designed in the 1930s. Gerard Fiennes, Jerry to everyone who knew him, formerly Gerard Francis Gisborne Twisleton Wycombe Fiennes OBE, line traffic manager at King's Cross from 1957, believed end-to-end speeds had to reach at least 75 miles per hour average if the East Coast route was to compete with road and air. He saw in the Deltic prototype the only diesel locomotive capable of sustained 100-mile-per-hour running at an acceptable axle load. In March 1958, British Railways ordered 22 production Deltics from English Electric at £155,000 per locomotive. The full order worth £3,410,000, the equivalent of roughly 85 million in today's money. They were to replace 55 Gresley Pacifics, including 35 of his legendary A4s. All 22 were built at the English Electric-owned Vulcan Foundry in Newton-le-Willows, delivered between January 1961 and March 1962. At 99 tons, each carrying two Deltic D18 to 25B engines, derated from 1,750 to 1,650 horsepower for railway use, they delivered the highest power-to-weight ratio of any diesel-electric locomotive in the world. The fleet was allocated to 3 depots, Finsbury Park, Gateshead and Haymarket, and named according to depot traditions. Finsbury Park's locomotives bore racehorse names from the Elner lineage: Royal Scots Grey, Meld, Crapello, Tulliar, Alicidon. Gateshead's carried the regiments of the North East, the Green Howards, the Durham Light Infantry. Haymarket's bore the Scottish regiments: Gordon Highlander, Royal Highland Fusilier, Argyll and Sutherland Highlander. Schoolboy train spotters knew all 22 names by heart, and the sound. A Deltic at idle in the cavernous train shed at King's Cross drowned out platform announcements. Charge ignition every 20 degrees of crankshaft rotation, smoothed over 6 cylinder banks, produced a high-pitched, almost jet-like scream, utterly unlike any other British diesel. At full power, with 2 18-cylinder Deltics at 1,500 RPM, the locomotive vibrated through the platform stones and into the bones of anyone standing within 20 feet. A departing Deltic could be heard for miles. That black exhaust cloud at startup, oil pooling in the exhaust manifold during cold standing, became as much a signature as the sound itself. On the East Coast Main Line in the 1960s, the Deltic didn't just run trains, it announced itself. Once the full fleet was in service in 1962, the London-Edinburgh Flying Scotsman timing was cut from 7 hours to 6. By 1973, average speeds exceeded 71 miles per hour end-to-end, with a London-Edinburgh time of 5.5 hours. Railway journalist O.S. Nock recorded 104 miles per hour south of Thirsk in 1963. Number 55510 made the record books for completing 2 million miles in less than 11 years. Most of the fleet exceeded 3 million. Maintenance was, uniquely in British Railways history, contracted out to English Electric on a fixed-price 5-year service agreement, because nobody at BR understood the engine well enough to maintain it themselves. The banshee howl of a Deltic pulling away from King's Cross, accelerating through Gasworks Tunnel and out onto the main line towards Peterborough, is one of the most evocative sound memories of post-war Britain. For anyone who used the East Coast Main Line between 1961 and 1981, it's the sound of the railway working properly, fast, powerful, unstoppable. Chapter 5. The highest point. The summer of 1962 was, by any measure, the summit. All 22 production Deltics were now in service on the East Coast Main Line, and the transformation of Anglo-Scottish timings was already visible in the timetables. The Liverpool Works was running both Deltic engine production and a steadily growing turbocharger business that had been transferred from Acton in 1950, reaching over 2,000 units per annum by 1966. Naval Deltic orders from the Norwegian and United States Navies were under negotiation. At Acton, the works was building Gazelle turboshafts for the Westland Wessex and Bristol Belvedere helicopters and finishing Eland turboprop contracts for the Convair 240, 5140 and the Canadair CC-109. Total D. Napier and Son employment stood near 10,000, with additional facilities at Luton for flight development, Rains Park and Park Royal. The naming ceremony of D9019 Royal Highland Fusilier at Glasgow Central on 9th of September 1965 was perhaps the company's last truly confident public moment. A locomotive bearing the Napier name, celebrated in a great railway station, cheered by crowds who understood what the machine meant. But standing at that summit, the warning signs were everywhere, if you knew where to look. The Naiad, Napier's first gas turbine project, was already dead. it had never found a market. The Nomad turbo compound engine, which had achieved the lowest specific fuel consumption of any aero engine ever built, a remarkable 0.327 pounds per horsepower hour at 25,000 feet cruise, had been cancelled in April 1955 after £5,100,000 of development spending because its only intended application, the Avro Shackleton 4, had been abandoned. The Eland turboprop was unreliable. Convair 240 operators suffered constant trouble. The Acton site was hemmed in. Saber engine testing had been pushed to Park Royal as early as 1943 because the noise was too great for what had become a residential neighbourhood. And the Acton workforce was ageing. 3/4 of the shop floor men were between 50 and 65 years old by 1962. The generation that had built the Saber and the Deltic was approaching retirement, and there was no clear successor generation behind them. Every other British aero engine firm of stature, Rolls-Royce, Bristol, de Havilland, Armstrong Siddeley, had pivoted from piston to jet or turbine work in the late 1940s with major commercial success. Napier had pivoted too, but into a small engine niche that the larger firms could trample at will. Only the Gazelle had a viable market, and Rolls-Royce had its own Gnome helicopter engine ready to compete. Napier in the summer of 1962 was a company with a glorious present and no future. The Deltics would run for 20 years, but there would be nothing after them from Napier. No successor engine, no new program, no next chapter. The triangle that had conquered the East Coast Main Line was also, without anyone quite realizing it, the last great thing D. Napier and Son would ever build. The question that would consume the next 12 years was not whether Napier would decline, but who would administer the decline, and how much of the 154-year-old name would survive it. Chapter 6. The Gathering Storm. The forces that would destroy D. Napier and Son didn't arrive suddenly. They accumulated in white papers, in boardrooms, in the slow arithmetic of government procurement policy that treated Britain's aero engine industry as a problem of excess capacity rather than a source of national strength. The 1957 Sandys Defence White Paper was the first blow to land with real force. Duncan Sandys, Minister of Defence, declared that manned military aircraft were obsolete and that Britain's future lay in guided missiles. The paper didn't kill Napier directly, the firm wasn't building fighters, but it triggered a chain reaction across the entire British aircraft industry that compressed the number of viable engine manufacturers from 4 to, eventually, 1. If you were a small specialist engine firm without a major jet program, the Sandys White Paper was a death sentence written in policy language. The mergers began almost immediately. In 1959, Bristol Aero Engines merged with Armstrong Siddeley to form Bristol Siddeley. The 1958 government statement on aircraft industry reorganisation pushed firms to consolidate, leading to the British Aircraft Corporation in 1960 and Hawker Siddeley Aviation. The logic was industrial efficiency. The effect was to create a landscape in which only the largest firms could survive. Napier, with its specialist piston engine heritage and modest gas turbine portfolio, was precisely the kind of company this consolidation was designed to absorb. Arthur Skeffington, the Labour MP for Hayes and Harlington, would later summarise it with painful clarity in the Commons. The result of what has happened at Napier's is the result of government policy, the consolidation of the aircraft industry. Inside Napier, the post-war years had produced a string of technically brilliant engines that couldn't find markets. The Naiad gas turbine, Napier's first attempt at the new technology, never secured an application. The coupled Naiad, linking 2 engines to a single gearbox, went nowhere. The Oryx gas generator was abandoned. The double Scorpion rocket motor had a moment of glory in August 1957 when it helped push a Canberra to 70,310 feet for a world altitude record. But rocket motors weren't a business. The Napier ramjet program was wound up. Each cancellation narrowed the firm's future a little further, until only 3 products remained in active service: the Gazelle turboshaft, the Eland turboprop, and the Deltic diesel. The Eland was supposed to be Napier's bridge to the turbine age. Instead, it became a cautionary tale. Fitted to Convair 240 DAF 540 conversions and the Canadair CC-109, it suffered persistent reliability problems that damaged Napier's reputation with airline operators, precisely the customers the firm needed to cultivate if it was to survive in a post-piston world. The Gazelle, powering the Westland Wessex and Bristol Belvedere helicopters was the one genuine success. But Rolls-Royce had its own helicopter engine, the Gnome, and Rolls-Royce had something Napier did not: the political weight and the production scale to dominate British military procurement for decades. The Nomad deserves a particular moment of regret. Designed as a turbo-compound engine, a gas turbine recovering exhaust energy to drive the propeller alongside the main power section, it achieved a specific fuel consumption of 0.3227 pounds per horsepower hour at 25,000 feet. No aero engine before or since has matched that figure. It was the most fuel-efficient aircraft power plant ever built, and it was cancelled in April 1955 because the Avro Shackleton 4, its only intended application, was itself abandoned. £5,100,000 of development money gone. The engineering worked. The market didn't exist. Frank Halford, the man whose genius had created the Saber and whose instinct for the future had led him to resign the moment English Electric arrived, had seen it coming. He'd left for de Havilland in 1944 and built jet engines, the Goblin, the Ghost, that powered the Vampire and the Comet. Harry Tempest Vane had seen it too, in a different way. Back in 1932, he'd argued that Napier should revive car production, creating a non-aviation industrial base that might sustain the firm through the cyclical droughts of military procurement. The board rejected his proposal. Vane resigned. Two men, 2 decades apart, had each identified the fundamental vulnerability: total dependence on government aero engine contracts, and each had been ignored or forced out. By 1960, Napier's position was clear to anyone who cared to look honestly. The firm had one viable engine in the Gazelle, one fading engine in the Eland, one magnificent but non-aeronautical engine in the Deltic, and a growing turbocharger business that was profitable but carried none of the prestige or scale of the aero engine work. It was a company waiting for someone to decide its fate. The someone arrived in 1961. Chapter 7. The Stripping. The joint venture was announced in 1961. A new company, Napier Aero Engines Limited, would be formed jointly by D. Napier and Son and Rolls-Royce. Limited to take over Napier's aero engine business and the Acton engine factory. The language was careful: joint venture, rationalization, complementary capabilities. The reality was simpler. Rolls-Royce was acquiring Napier's aero engine work, and with it, the right to decide which Napier projects lived and which died. They nearly all died. The Eland was dropped. The Oryx was already gone. The Naiad and coupled Naiad were dead. The Nomad had been cancelled 6 years earlier. The ramjet work was wound up. The double Scorpion rocket motor, which had set that world altitude record just 4 years before, was finished. The only survivor was the Gazelle turboshaft, kept because Rolls-Royce needed it for the Westland Wessex program and didn't yet have a replacement ready. Within 2 years of the joint venture's creation, every Napier aero engine project, except the Gazelle, had been killed. The pattern was not unusual by the standards of post-1960 British industrial consolidation. It was, in fact, exactly what government policy had intended: fewer firms, fewer overlapping programs, lower costs. But for the men and women who worked at Acton, the policy arithmetic looked very different from the inside. In August 1962, English Electric and Rolls-Royce issued a joint statement announcing the closure of the Acton factory of Napier Aero Engines Limited, with more than 2,000 redundancies. 2,000 people in a single announcement. The phased closure ran from August 1962 to August 1963. By early March 1963, when the member for Acton, Philip Holland MP, brought the matter before the House of Commons in an adjournment debate, the numbers told the story in terrible specificity. 543 hourly paid employees had already left. 435 remained. Of the more than 1,000 total staff who had departed, 65 were registered as unemployed and 11 with the professional and executive register. Of 202 apprentices caught in the rundown, 176 had been transferred to other companies, 18 had been offered vacancies, 5 were in interview, and three young men, whose training had been interrupted by a boardroom decision made hundreds of miles from their workbench, were still without placement. Holland read out a case that has stayed in the parliamentary record for over 60 years. A 60-year-old craftsman, unnamed because Holland was protecting his identity, but real, documented, spoken to by a friend who reported it to the MP, had told that friend he wished he were 5 years older. He would wish 5 years of his life away in order that he could retire honourably, instead of being thrown prematurely on the scrap heap. A man who had given his working life to D. Napier and Son, wishing away the years he had left so that the ending might carry some dignity. The Commons debate of 8 March 1963 was one of those rare parliamentary moments where the language matched the gravity. A.E. Hunter, the Labour MP for Feltham, put it plainly, one of the oldest firms in aircraft engineering, a firm with a famous name, and apart from the human tragedy of the men who are losing their jobs, it is a national tragedy that Napier's is to go. Arthur Skeffington, MP for Hayes and Harlington, traced the cause to its source. The result of what has happened at Napier's is the result of government policy, the consolidation of the aircraft industry. William Whitelaw, then Joint Parliamentary Secretary to the Ministry of Labour, offered sympathy and statistics about redeployment. Nobody offered to reverse the decision. The Shop Stewards Committee at Acton behaved, in Holland's words, with constructive cooperation through the rundown. There was no work in, as there would be at Upper Clyde Shipbuilders 8 years later. No alternative plan, as Lucas Aerospace workers would produce in 1976. No mass protest, no picket lines, no television cameras recording scenes of resistance. The men of Acton accepted the closure with the quiet, bitter dignity of skilled workers who understood that the decision had been taken above their heads and that no amount of protest would unmake it. They signed off, they cleared their benches, and they left through the gates of a factory their fathers and grandfathers had walked through, in some cases for 3 generations. The question of whether this constituted corporate murder has a nuanced answer. There is no documentary evidence, parliamentary or otherwise, that Rolls-Royce engineered Napier's destruction from outside. English Electric had bought the firm 20 years earlier. The 1961 joint venture simply gave Rolls-Royce access to the aero engine work that English Electric no longer wanted to fund, but the effect was indistinguishable from elimination. Every project killed. The works closed. 2,000 jobs gone. The Napier name driven permanently out of the aircraft business. The honest documentary verdict is, not quite murder, but the patient didn't survive the treatment. Chapter 8. The Long Erasure. The closure of the Acton Aero Engine Works in 1963 was not the end of D. Napier and Son. Not quite. The company continued as an English Electric subsidiary, based primarily at the Liverpool Works on Dunningsbridge Road in Netherton, building Deltic engines for the Royal Navy and turbochargers for marine and industrial applications. The Deltic locomotives were still running, magnificently, on the East Coast main line. The turbocharger business was growing. The name survived, but the name was now attached to a diminishing enterprise. The total Napier workforce, which had stood near 10,000 at its wartime peak and still numbered in the thousands through the 1950s, had fallen to 1,632 by February 1967 across both remaining sites. The firm that had once built the world's most powerful aero engines, the world's fastest land-speed record cars, and the only diesel locomotive capable of sustained 100-mile-per-hour running, was now, primarily, a turbocharger manufacturer that happened also to build a specialist naval diesel. In 1968, the next corporate capture arrived. Plessy launched a hostile bid for English Electric. The government, alarmed at the prospect of Britain's heavy electrical engineering industry falling to a firm it considered too small for the job, brokered a counter-takeover. Arnold Weinstock's GEC absorbed English Electric to create a combined GEC-AEI English Electric conglomerate with 250,000 employees. D. Napier and Son, already a subsidiary of a subsidiary in practical terms, was now buried 3 layers deep inside a vast industrial holding company run by a man whose reputation rested on financial discipline, not engineering romance. Weinstock's GEC was methodical. The Acton site, which had been running at reduced capacity since the 1963 aero engine closure, was shut down completely in 1969. The premises that Montague Napier had built in 1903, the stone-faced brick factory with its Piccadilly Circus foyer, the works that had produced lions and sabers and gazelles, the 8.5-acre site that had once employed 1,700 people in a single wartime year, fell silent. The silence was not temporary. It was final. By 1970, GEC was centralising its diesel engine operations at the Ruston Paxman Works in Colchester. Deltic production was transferred from Liverpool to Paxman. The engine that Chatterton, Barlow, Murray and Salmons had designed at Acton, that had been built at Liverpool, that screamed up the East Coast main line in the most charismatic diesel locomotives Britain had ever produced, became a Paxman product. The Napier connection was severed. Turbocharger production was moved to GEC's site in Lincoln, where it continues today under different ownership. The Liverpool works on Dunningsbridge Road wound down its Napier-badged production around 1969 to 1970. Aerospace component work continued at the site under Lucas Aerospace until that company announced closure of its Liverpool operation in 1978. On the East Coast Main Line, the Deltics ran on, magnificently, stubbornly, as if unaware that the company which had created them no longer existed in any meaningful sense. Ray Smith of Doncaster Works led the maintenance team that kept the fleet operational after British Rail took over from English Electric's service contract. When a cylinder liner failure threatened the entire fleet in 1970, it was Smith's team that developed the fix, eventually extending engine hours between strip-downs to 7,500, a remarkable achievement for a power plant that the London Midland region's J.F. Harrison had once dismissed as too fragile for railway use. By the mid-1970s, the high-speed train prototype was running trials on the Western region. The Intercity 125 would enter service in 1976, offering sustained 125-mile-per-hour running with Paxman Valenta engines, a conventional, reliable, maintainable power plant that made the Deltic's exotic complexity look like an engineering indulgence. The writing was on the wall. British Rail began planning the Deltic fleet's withdrawal. On 16th December 1974, the name D. Napier and Son Low Altid was formally changed to Napier Turbochargers, Year Altid, 166 years. David Napier's walk into Maudslay's workshop in 1808, James Murdoch's precision coin machines, Montague's six-cylinder cars, Edge's Gordon Bennett Cup, the Lion, the Saber, the Deltic, 10,000 workers, 1 million square feet of factory floor, speed records on land, water, and in the air. 166 years, ended by a Companies House filing and a new nameplate. Nobody held a ceremony. Chapter 9. The Last Departure. The Deltic locomotives outlived the company that conceived them by 7 years. British Rail withdrew the fleet progressively from 1980, replacing them with the Intercity 125s and the new Class 254 HST sets. The machines that had transformed the East Coast Main Line, that had cut London-Edinburgh from 7 hours to 5.5, that had covered 3 million miles apiece and screamed through stations at speeds no other British diesel could match. They were pulled from service one by one, their nameplates removed, their engines silenced. The last Deltic hauled service arrived at King's Cross on 2nd January 1982. It was 55215 Tulia, bringing in the 1630 from Aberdeen. Television news cameras recorded what happened next. The platform was packed, not just with the railway enthusiasts who'd been following the withdrawal for months, but with members of the public who understood, at some instinctive level, that they were watching the end of something that mattered. One man knelt and kissed the locomotive. Drivers blasted their horns. Fans were, in the description of one witness, virtually hanging from the rafters. It was the kind of public mourning that the British reserve for things they didn't realise they loved until the moment of losing them. The Deltic Preservation Society had been founded 5 years earlier, in 1977, by enthusiasts who'd seen the withdrawal coming. They were granted charitable status in 2003 and today operate a depot at Barrow Hill Roundhouse, near Chesterfield. 6 of the 22 production Class 55 Deltics survive, the highest preservation percentage of any British locomotive class. D9000. Royal Scots Grey sits at the Hornby Museum in Margate. 5002. The King's Own Yorkshire Light Infantry is at the National Railway Museum in York. D9009. Alisadon remains mainline certified, maintained by Deltic Preservation Society volunteers at Barrow Hill. D9016. Gordon Highlander is at Margate. D9019. Royal Highland Fusilier is at Barrow Hill. D9015 Tuliar, the locomotive that made that final run into King's Cross, is undergoing major overhaul at Barrow Hill. tended by men who refused to let the sound die. The prototype, DP-1, its engines long since stripped for Royal Navy spares, sits at the Locomotion Museum in Shildon, having passed through the Science Museum, the National Railway Museum at York, and the Ribble Steam Railway. It is an exhibit now, a thing behind a rope, the machine that proved the concept, that ran the Shamrock and the Merseyside Express, that convinced Jerry Fiennes the East Coast could be saved, reduced to an object of respectful curiosity in a County Durham shed. A preserved Napier Lion still runs in the Napier Railton car at Brooklands Museum, the same engine type that held the Worldland speed record for 16 years. Saber 2IA exemplars survive at the Smithsonian and the RAF Museum. The Napier Power Heritage Trust, an enthusiast historian organisation, maintains the company archive under the shelfmark NAP at the Institution of Mechanical Engineers. In 1971, 3 years before Napier's own name was erased, Rolls-Royce went bankrupt over the RB211 turbofan development crisis and was nationalised as Rolls-Royce, 1971 Lithad. The company that had absorbed Napier's aero engine work, that had killed every Napier project except the Gazelle, that had closed the Acton works and made 2,000 men redundant, fell itself, brought down by the same pattern of over-ambition and undercapitalisation that had plagued Napier in the Saber years. The Bristol-Siddeley merger of 1966 had given Rolls-Royce a monopoly of the British aero engine industry. The monopoly nearly killed it. Chapter 10. The silence in the wrong shape. The Acton site today is Seagrow Park, Acton, an industrial and warehouse park on the Vale between Larden Road and Valletta Road, managed by Seagrow plc. Standard West London industrial estate, brick and steel warehouse units, CCTV cameras, the hum of HGV engines and forklifts, the Grand Eastman concrete office block of 1916, the building that once faced Acton Vale as the public face of one of Britain's most extraordinary engineering firms, still stands, refaced in glass, currently used as an access self-storage facility. You can rent a unit by the month, store your furniture, your boxes, your surplus, in the building where men once assembled lions. The Park Royal test houses on Coronation Road and the development complex on Alliance Road are gone, absorbed into the broader Park Royal industrial estate. The tunnels where Sabers and Nomads and turbocharged Deltics ran through the small hours, keeping Ealing awake, are built over. The Liverpool site on Dunnings Bridge Road in Netherton was redeveloped into an industrial park. The million-square-foot factory that built 3,500 Sabers and 500 Deltics is gone. No trace of the buildings, no memorial plaque, no acknowledgement that this was once one of the largest precision engine factories in Britain. But there is a road, a short industrial road in the Bootle estate, postcode L31SL, near the junction with Park Lane just off the A59. It's called Deltic Way. The connection to Napier is not publicly signed. Sefton Council's street naming records almost certainly hold the origin, but no publicly available source explicitly confirms it was named for the engine. The inference is overwhelming. The road sits on the exact site of the Napier and English Electric Works, where every production Deltic engine was manufactured. It is the company's only memorial in Liverpool. A road name on an industrial estate, leading to a logistics warehouse, carrying the name of an engine whose scream once echoed across this ground. Acton, in 1932, had 5,400 motor industry workers, 4/5 of its entire industrial workforce. The post-war losses of Napier, Wilkinson Sword, Cav Lucas, Eastman's, W&G Ducros, and others left the borough, as Philip Holland told the Commons in 1963, with unemployment much higher than we have known it for quite a long time. The communities that had organised themselves around these works, the pubs, the corner shops, the terraced streets within walking distance of the gates, lost not just employment, but purpose. A works doesn't just provide wages. It provides a reason for the streets around it to exist. When the works goes, the streets remain, but the reason doesn't. The Napier name survives in Lincoln. Napier Turbochargers LLC, a subsidiary of the American transport technology conglomerate Wabtec Corporation since 2014, continues to manufacture marine and rail turbochargers under the Napier brand. The turbochargers are good, the work is real, but it is not the same company. It is a brand applied to a product line owned by an American conglomerate, 3 corporate captures removed from the firm that David Napier founded in Lloyd's Court in 1808. The phrase D. Napier and Son is owned by the Napier Power Heritage Trust. Volunteers maintain the archive. Enthusiasts keep the Deltics running at Barrow Hill. A handful of men and women, working without pay, hold the line against forgetting. A walker on the Vale in Acton, on a quiet afternoon, would not know that for 50 years this was one of Britain's most extraordinary engineering sites. There is no blue plaque, no heritage board, no information panel explaining that here, behind these warehouse walls, men designed an engine so advanced it held the world land speed record into the 1960s, built the power plant that helped win the air war over Northern Europe, and conceived a triangular diesel so demented in its complexity and so magnificent in its performance that schoolboys memorized the names of every locomotive it powered. The silence is wrong here. A site built for noise, for the scream of Sabers on test, for the throb of Deltics being tuned, for 1,700 pairs of boots on concrete, occupied now by the low hum of refrigerated lorries and the beep of reversing forklifts. A silence in the wrong shape. David Napier walked into Maudslay's workshop in 1808 with nothing but a blacksmith's grandson's hands and an engineer's eye. His great-grandson Montague rescued the firm from 7 men and built it into a name that meant speed, precision, and the relentless pursuit of more power from fewer parts. The Lion held records. The Saber won a war. The Deltic, that impossible triangle, 3 crankshafts, 18 cylinders, a sound like nothing else on earth, gave Britain its fastest railway for 20 years. None of it was enough. Not the genius, not the records, not the craftsmanship that put 2 opposed pistons in a single cylinder and made them sing. Government policy compressed the industry. English Electric absorbed the firm. Rolls-Royce killed the projects. GEC closed the works. And on 16th of December 1974, a Companies House filing erased the name that David Napier had carried south from Dumbarton 166 years before. Not through one catastrophe, through a sequence of reasonable decisions, each one logical, each one defensible, each one moving the work a little further from the hands that understood it, until the gates closed and the silence settled, and the only trace left in a city of 8 million people was a self-storage unit on a road that used to be a factory.